Hello, everyone, and welcome to our webinar about document agents for finance. I think I'm going to give this another maybe 30 seconds to allow people to pile in, and then we'll give this a start. All right. Okay. So thank you very much for coming to our webinar about document agents for finance. Before we start the actual content, I want to do a few notes about how this is going to run. So I've already seen a few comments pile in about the recording. Yes, we are recording this, and hopefully if all goes well, soon after the session ends, we will be uploading the video to YouTube. I also have my lovely colleague Murtaza in the chat. He'll be helping out answering questions along the way, but hopefully we will also have some time at the end to answer some questions, and I can do that live. And all resources will be shared in the chat along the way, as well as the description of the recording once this is done. And if you want to rewatch it on YouTube, I'll make sure that all of the notebooks we go through, etc., everything is there for you. And without further ado, I think we can start with the session. So a quick recap into what I'm going to be talking about today. It actually boils down to a very simple task. Imagine investment bankers, people who work in your accounting teams, anyone working in finance. They're often faced by pretty complex documents and files. And everything we're going to be talking about today is going to be about how we leverage AI agents and language models and language vision models to make these people's lives a lot easier by extracting structured information out of them and then doing something with that information for them, hopefully making their lives a lot easier and making the tasks they have to manage a lot faster. So AI agents, we have come to a point in the AI community where we now know that they can automate knowledge work, and we're already seeing a shift from classical RAG chatbots to task-specific document agents. And a lot of the content we'll be sharing today is about these task-specific document agents. There will be some code towards the end. I hope to show you, if not run the entire thing, I hope to show you a fund analysis for asset managers. There will be some Python code. We'll also have a look at LlamaCloud as well. So before we start with that, I want to start talking about one of the main struggles and challenges we have when it comes to knowledge agents or document agents. And the fact is that a lot of the knowledge and the documents that people, especially since the theme is finance, we can talk about finance. A lot of it, what we deal with is based on complex file types, anything from PDFs, PowerPoint, Word, Excel, etc. And the challenge with this is really that all of these documents have been created with humans in mind. They are generated or they're created by humans for the consumption of humans. But now with AI agents becoming a lot more capable, we need to make sure that they are also consumable by agents. We've already seen people start using these documents with what we now can call naive RAG chatbots. But our aim is to start using these types of documents with document agents to start to automate processes such as document research. We already see a lot of these, extraction and processing, report generation. And these final two, I think, are probably a bit more relevant to the type of financial documents we're going to be looking at today. So I'll be explaining how we build document workflows that do extraction and processing and report generation like tasks. So to give you an example of the files we talk about, here are 3 screenshots. They look very messy, and I made sure they looked very messy because they're great examples of what the challenge is. So here we have some examples of, for example, the NVIDIA SEC filing. It's a 10K form. We have an annual report for some funds on the left. we also have an example of an invoice. And pretty quickly, you might be able to notice a few things about these documents. They are quite messy, they're complex, the layout is not necessarily uniform, they can have lots of charts and tables and figures in them, and they're definitely also not uniform across different, for example, invoices or SEC filings, etc. So to build knowledge agents that are capable of working on this, before I get into how we parse and extract information from these types of documents, I also want to do a quick intro into what we mean when we say agents. So in the grand scheme of things, I think we can group agents into two main categories. Assistive agents who help humans get more information faster. So you can think of these as agents that sit alongside us for any given task. And you can also think of automation agents, where it basically does what it says on the tin. These automate routine tasks in the background, and they take actions on behalf of us. And I think what we're going to be looking at today possibly falls into the latter category a lot more than it does the former. But there are also a few necessary ingredients. When we talk about architecture, we talk about tools to surface relevant context to LLMs, and architecture, which basically is a way for us to codify our business logic. And we're also going to be talking about the architecture of these document agents as well. So a quick word about Llama Index, just in case there are people here who are not aware. We have two main products. We have LlamaCloud, which is our enterprise solution for a lot of these, what we call agentic document toolboxes, which allows us to automate extraction with vision language models and LLMs, parsing, which goes beyond OCR to parse complex documents in a context-aware way, which we also have LlamaCloud Index, which allows us to embed and store really huge amounts of data and work off of them. Then we have our open source framework, which really is a tool that we talk about when we talk about orchestrating and architecting our business logic, our agentic document, our document agents logic layer. And at the end of this, hopefully you're able to construct a specific solution for a task you might have in hand, for example, financial analysis or invoice processing and so on. In this talk, I think the main focus is going to be around parsing and extraction. For parsing, we'll be able to parse documents that have images, tables, charts, etc., in a much more context-aware way. And extraction is going to be the first one we start with. So without further ado, let's have a look at how we might tackle the task of extracting the most relevant information to us from an NVIDIA SEC 10K filing. So at the end of the day, we want to be able to get only the information that we're after from this pretty large document. So there are two ways we can do this. And I'm just going to maybe add my other screen here, and we can switch to LlamaCloud for a sec. Maybe Murtaza, if you can help me remove this screen and add the LlamaCloud screen. Great, okay. So there are two ways we can use Llama Extract. So I'm going to quickly switch to Extract, and we can have a look in LlamaCloud. Here you can see a bunch of extraction agents we have. And for example, let's have a look at this one called Filing Parser. Here you can see that I've got already a schema defined. We're looking for company name, description, filing type, filing date, and so on. We can also choose to use one of these predefined schemas, and 10K or quarterly filings are also one of these here. That is one way of doing it, but the other way of doing it, which is, let's remove this and add this back, in a programmatic way, is to define our own schema programmatically from scratch. So here you can see I can define my own Pydantic model. At the end of the day, I want to result in a financial report. So this has company name, description, filing type, filing date, fiscal year, revenue, and unit. I can do this and simply create my Llama extract agent and call it filing parser. And if I then run this, you would get the results that you saw in the cloud screen just before. So let's go back to that. Sorry, there's going to be a bit of back and forth here. Let's add that. And let's have a look at extract results. So as you can see, I've run the NVIDIA 10K PDF through this quite a few times, and I can have a look. And a few things that I can see already is the company name that I was after, the description I was after, the filing type, and so on. The other thing I can see, which is pretty important when we come to bring these types of extraction agents into production, and we want to make sure that the extracted results are what we expect, we have the option of adding citations and reasoning to the extracted results. So, for example, here we have a matching text for one of the fields. We have a described reasoning behind it, and so on. And sometimes you'll see that the reasoning is that it's verbatim extraction, which basically means that the filing type was specifically mentioned verbatim in the text. All right. Let's go back and add this back. So we have seen so far one ingredient of what we might be using when it comes to building document agents, especially when it comes to extracting information from financial documents. But when it comes to building an agent, we actually have two maybe large steps we go through. This is data parsing and ingestion. This is preparing our data and putting it in our index. And next we have data querying, which consists often of retrieval, prompting an LLM, and response. I'm going to quickly have a look at the question that came through. We find that it gives more control in terms of meeting the right balance between cost and accuracy. I missed that. Murtaza, do you mind adding it back on? Or I will maybe answer it at the end. Okay. So we're going to have a look at what we might do to build a end-to-end workflow. So we saw the first three boxes here. We saw defining a schema, creating an extraction agent, extracting that data, and we got a response. But then what we do with that response is basically up to us completely up to us. So we're going to have a look at how we might go about creating a complete end-to-end solution with one of these ingredients in mind. So this brings me to Llama Index agent workflows. We're going to be looking a bit more into detail when in this the workflow building process, but basically this is our agent orchestration framework, which is completely open source. It is a Python framework. It's an event-driven framework, so I'll tell you a bit about what that means. It's composable, which means that we can mix and match different tasks, and we can also customize. It's pretty flexible, and because of the event-driven architecture, it's pretty debuggable and observable as well. So this is where we start going into a bit more Python code, and in a bit we're going to switch over to Colab to build an end-to-end fund analysis agent workflow. So a few things you have to understand about Llama Index workflows is that it consists of two main components, steps and events. Every step is basically a function with the step decorator, and they can consume events and emit events. So the workflow that you're seeing on the screen right now is a completely legit workflow. And you can see that step one is expecting the start event. So this is the entry point into our workflow, and it's emitting an event called first event. We can also visualize these workflows, which is pretty neat because it allows us to visualize the type of business logic we're embedding into our agent workflow. And another thing that they can do is that they can branch out loop. So we can have steps that are effectively decision nodes in our agent workflow graph, if you will. And the way we bring all of this together is that if you look at this graph, the left-hand side is basically everything that we have in terms of knowledge management, parsing, extraction, indexing, storage, all of that comes with LlamaCloud. But when it comes to designing what our end-to-end agent task is, this is where we use Llama Index, which integrates with a bunch of model providers, and you have full control as to what your agent does at each step, specifically embedding your own business logic in there. So this is what we're going to have a look at. On the left-hand side here, you see a screenshot from an annual report from Fidelity Funds, and we want to build an agent workflow that's able to parse this document, and we're going to be using Llama Parse for that task. It's going to split up the document per fund, and then it's going to extract the key information we're after to then eventually produce this report that combines all of the funds and all of the fields that we're after in one easy to digest format. So this is what we're going to be building. Initially, we'll have the single PDF document. We're going to split the context of that document per fund. There are quite a few funds that are mentioned in this document. We're going to group them per page and per fund. And then we're going to, given all of those chunks, we're going to extract the relevant information that we're after to produce this pandas data frame. And with that, I'm going to, again, maybe this time, Murtaza, if you can switch over to my other screen, and hopefully you guys can already see it. So I'm going to start explaining. So this is the workflow that we're going to try to end up with. So to begin with, I've already got my fidelityfund.pdf. We install all of our required packages. And then we also need our LlamaCloud API key. And in this case, we are using OpenAI. So here I have my OpenAI API key. I have my project ID and organization ID. I will be sending this collab to everyone to use. So you do have to change your project and organization ID if you want to use this as well. And I'm just going to do some set some settings for the embedding and LLM that I want to use. All right, so to start off with, we want a way to effectively parse our fidelityfund.pdf. So I will be creating a parser. I'm going to ask for the result to be handed over as Markdown. This is pretty easy to digest for most LLMs. And I have my parser ready. The next I have hidden for now because there's a lot of code here, and this is what it's basically doing is it's finding the splits per category, and we've asked the category to be the name of the Fidelity Fund. And then we run some examples and to see what we result in. Next, since I've got my parser, I want to also create my extraction agent. My extraction agent is going to be producing this schema. It's called fund data. It's got a bunch of fields and descriptions for those fields. For example, fund name, full fund name, exactly as it appears. For example, Fidelity Asset Manager, 20%, and so on. And it has quite a lot of fields that we're after here. I also have a fund comparison data model here as well that's used. All right. Now that I have this schema, I can go ahead and create my Llama extract agent. What's happening here is that I am, first of all, initializing Llama extract, and then I'm, in this case, just to make sure that we're not duplicating anything, I'm checking if I already have an agent called fund data extractor. And if I do, I delete it, and then I'll be creating a new one. So if I switch here, I think we'll be able to see that I do, in fact, have an agent called fund data extractor 2. So that will be deleted, and we should have a new one. Maybe I can run this again, and we'll see how it goes. If it takes too long to run, that's fine, because I ran this just before the webinar started, so we can have a look at the results as well. Now that we have this, we're going to be creating our workflow from scratch. So we're calling this workflow Fidelity Fund Extraction. It has two main events that we define. We also have some events that are default to Llama Index workflows, the start event and the stop event. We're going to be producing the parse doc event and doc split event. And here we are defining our steps. the parse doc step, which is calling our parser with our Fidelity Fund PDF. Next, we have our find splits, which is producing our doc split event. And finally, we have our run extraction step, which is using our extraction agent to then extract the relevant data. And on top of that, we return all of the results in a pandas data frame. The other thing that we've done with this particular workflow is to make it just a bit more flexible for different types of files. We've also made it so that we initialize it with a split description. So this is a description as to how we want to split our incoming file, split rules and split key, which I think we can also we can always have this as a default value. But what we've done here now is that now we have our parser, our extraction agent that is expecting to produce our fund data schema. We can run this whole task as one single workflow where the description is find and split by the main funds in this document should be listed in the first few pages. And our split rules are these bullet points. I run this. I can also draw my workflow, but you saw the resulting workflow already. And then finally, I can have a full end-to-end document agent workflow that's able to run on my single file path. So once I run this, the fidelityfund.pdf, the resulting data frame I have is the following. All right, so that's just one example of how we can implement workflows end-to-end that's able to both make use of AI parsing to parse complex documents, as well as extraction that basically makes use of the LLM that we use. Most LLMs that we use these days have structured outputs as a feature. We're basically making use of that and running jobs in the background that is able to extract from documents that may have lots and lots of pages. The cool thing about this particular workflow is that once we have all of this data, we can also run some experimental analysis over the data that we have. And for example, here we are installing Llama Index experimental, which is allowing us to make use of the pandas query engine, which then allows you to talk with that produced pandas data frame and get human language responses to the data within that data frame. So here, for example, I can ask my pandas query engine, show me all the funds where the actual equity allocation is more than 5% higher than the target. And not only do I get the resulting pandas data frame here, but I also get a easy to digest explanation as to what we're looking at here. All right, with that, I will switch back and remove this and add this back to the screen. We've already done that. And this brings me to a short segment I wanted to add to this pretty last minute about the future of vibe coding when it comes to document agents. So a lot of the workflow that you saw just now can be easily grouped into the automation agents that we were talking about. We do now see a lot of way more, I would say, effective assistant agents when it comes to coding assistants. And we are also noticing that the future is probably in between us building workflows from scratch and also describing to coding assistants exactly what we want out of the workflows and getting these assistants to generate code for us. So an example of that is a Streamlit application we were able to create by simply providing the workflow code that we had already had when it comes to invoice processing and provide that as context to Cursor. The resulting Streamlit application is actually pretty impressive. It allows us to drag and drop invoices and extract invoice data, making use of an extraction agent we already have in LlamaCloud. And another thing that I want to show, since we have a bit of time, is a command line tool that allows us to generate Llama Index workflow code from scratch. And with that, again, I'm going to switch over to my screen. All right, so this is the resulting Streamlit app that you see. And let me switch over to Cursor here. Here we have a Cursor prompt that is explaining to Cursor exactly what kind of application we want. And we have a sample.py, which is a sample of the workflow that we want the Streamlit app to serve for us. Providing this pretty long prompt, exactly explaining what kind of UI we want and how we want our workflow to be served, we're able to, let me scroll up and I can show you what the interaction was. We're able to drag and drop our cursor prompt as context and say, here are some instructions on how to create an app for an invoice extractor. Cursor comes up with a plan. We can have a look at the plan, check if it's okay, and then say proceed. And then Cursor basically dumps out a invoice app, Streamlit app that we can run. And that is the app that you see right here. Another thing we can do, and I'm going to see if I can actually demo this live. So let's see how that goes. This is our no-code workflow generator. It's a CLI where I can start a AI agent CLI, which then asks me about what I want to do. So in this case, I want to generate a workflow. Let's say generates workflow. All right, so now it's asked me to give a clear description as to what I want the workflow to do, if there are any reference files or directories that it could use as example. So I'm going to use the example that was provided in the README here, and hopefully I can find it easily. Okay, let's say generate a workflow to extract financial data from 10. I'm going to actually make this 10 Q reports because I know I have example 10 Q reports. And use examples. I think we have examples, test input files, test 10 Qs as reference. And hopefully that's fine. And while it's doing that, while it's doing that, I can show you, hopefully if it's still here, the workflow that was generated the last time I showed this. So here is the workflow that was generated. This is the financial data that it's decided to extract. We did have some example Pydantic schemas already ready. It created an extraction agent. It also created a parser, and then it created something called your workflow that's expecting the parser, the extract agent, and so on. Here it's said it's created the workflow successfully, and now it's generating business runbook. This is a markdown file that explains what's going on and how to run it. And here you can see our Llama Index workflow with all the steps, parse document, extract data, analyze results, and so on. And again, from our previous run, you can have a look at, hopefully, the resulting CSV. So this is 10Q consolidated. It's a CSV file that is generated from one of the example files we have here. All right, I'm going to let that run in the background, and maybe if we have time, we can go back to it. All right. With that, a few final words. So far, the two main products you saw within LlamaCloud have been Llama Parse and Llama Extract, both of which myself and our colleague Clelia created N8N nodes for, which you can try out. And this is a great example of using LlamaCloud products in maybe pre-existing business logic which is implemented in N8N-like workflow generators. You can have a look at a YouTube video where we explained how all of that works as well. Finally, this is a big one. Everything that you see in LlamaCloud is also runnable as an MCP tool with an MCP server. Again, here is a video where we explained how you can run these as MCP tools and MCP servers. An extra little information, LlamaIndex workflows that you create can themselves also be served as MCP servers with one of the latest additions we made to the framework. And with that, I think I can take some questions, Murtaza. I think maybe the first question that came up was by mistake. I'll let you decide what to ask. Curious to see the chunking and retrieval strategy used for this. How is the metadata stored? Yeah, I can definitely show that. I did just decide to skip it because it's quite a lot of code, and I thought maybe we can focus on the workflow itself. Basically, what's happening is that we're using Llama parse to parse per page, but we're also then using our own little function that uses an LLM with a clever prompt to then check each page to decide which fund it's talking about, and then assign relevant. So basically, we have keys as fund names and all of the relevant pages, and then we basically chunk based off of that. So that way we don't have to send the whole document to the extraction agent. We can send per chunk, which is basically per fund, if that makes sense. And we create the metadata ourselves before we send it over to Llama Extract. Metadata being fund name and chunk reference or page number. Can these agents be run regularly to find new documents as opposed to user having to monitor when a new document press release comes out? Yes, and I think this is, I would argue, one of the main use cases of integrating LlamaCloud tools like Llama Extract and so on into LlamaIndex workflows, but also N8N. N8N is a great example. So let me switch over to this view here. For example, and this can be built with LlamaIndex as well. This is just a convenient way to do this because we have nodes already ready. The concept we had in mind for this is that whenever there is a change in a specific local folder, so in this case, I had a folder called invoices. Whenever there's a change in the invoices folder, i.e. a new invoice comes in, we then trigger this whole workflow to send to the extract agent, which then emails the relevant party that there's a new invoice with all of the relevant information from that invoice. So no embedding or storage in a vector database. Mostly yes, because mostly we want to also be able to do RAG-like search and question answering on these documents. For this specific fund analysis and asset manager, for asset managers, no, there was no storage involved. We didn't use LlamaCloud Index, but for a lot of other use cases, we would. Even for this one, we would, if we want to provide a system where the user is asking questions and we want to provide answers to that. For example, the final pandas query engine you saw where we're able to, this was an experimental tool, by the way, where we're able to ask questions about the data frame, create new data frames from the structured information we have. We could have also done something very similar by embedding all of the data and doing vector search over them. So I think no and yes. No, not specifically for this example we went through, but yes for most use cases. I think it's a judgment call. Any other questions? All right. Well, Murtaza, I'll let you make the call. I think we're nearly just on time with 40 minutes. I will be sending all of the code that you saw to everyone that's registered. but we'll also be adding them into the description of the video. I also noticed that I probably didn't properly introduce myself at the beginning. I am Twana, and I am in the developer relations team here at LlamaIndex. Thank you.